For this lesson, we're going to be looking at prime factorization of a number, and we're going to be using factor trees. So let's look at some of the vocabulary that you really should know. First of all, a prime number has only two factors, one and itself. So an example could be 3. Because we know that just 3 times 1 is equal to 3. So 3 is a prime number, 5 is a prime number, 7 is a prime number. Those are all numbers that only have themselves, and 1 is a factor. So when I'm talking about factors, well, they're numbers multiplied together to get a product. So we're going to be looking at trying to make sure that as we factor 24, all our numbers are prime numbers in the end. So let's look at the procedure. So I have 24. I want you to think of two numbers that you multiply together to get 24. And I just make a little mark like that, which reminds me of branches of a tree, a factor tree, and I'm going to pick 4 times 6. It does not matter which numbers you pick as long as you break the numbers down properly into prime factors. Well, I know 4 is not prime because, and notice I'm putting my branches there, 2 times 2 is equal to 4. And then notice I'm going to bring down this times sign, and now I'm looking at 6. Well, we don't want to do 6 times 1. That's just not going to help us. Oh, but what about 2 times 3? So as I'm looking at this problem, notice I started with 24. I broke it down just to 2 factors, and then each factor I broke down into factors that are actually prime numbers. And I know that I'm done when I have 2. That's prime because it's 2 times 1. We have another 2, another 1, and then a 3. And we said 3 was prime. We had it over there. So this actually could be your answer, or you might be asked to write it in exponential form. And all you do for that is I have 1, 2, 3. I have 3 2s. So I'm writing it that way. And I just have 1, 3. And it's just an understood 1 there. You do not have to write it. So depending on what the teacher asks or the book asks, either one of these answers are correct. All right, so let's look at 50. Well, it's even. So I think I'm going to break it up into a 2 times a 25. All right, well, wow, 2 is prime. So I am bringing it down. And notice I just bring it down with one branch. And so it's not forgotten. All my numbers should always be on my last line. And now I'm going to bring down this times sign. And 25 I know is not prime because I can break it up into 2 factors of a 5 times a 5. So I'm looking, are these all prime? Yes, they only have the number and 1 as a factor. If I wanted to write it in exponential form, it would be 2 times 5. And since there's 2 of them, I'm going to write to the second power or squared. Again, either one of these answers would be correct. So let's look at number 3. I have 78. And again, sometimes it's just hard to think about the different factors. So, I know this is even. I'm going to divide 78 by 2. So I'm starting off with my 2 times, and 78 divided by 2 is actually 39. Okay, I know 2 is prime. I'm bringing down my times sign that's already there. Now, 39 might be a hard one for you, but the divisibility rules tell me that if these add up together and it can be divided by 3, then I know 3 goes into there. So, and if you don't remember divisibility rules, check out Math with Marcia. They're there. So this is 3 times 13. And I know 2 and 3 are prime, and guess what? 13 is also. So this is my answer, and that is even my answer. There's no exponential form because every factor was just listed once. Okay, well, let's get to the last one. And the last one is 100. I'm going to draw this little line here so that we know that our problems are all separated so that you see it, and especially for this one, I don't want to run into any of my other problems. All right, 100. Well, what about, there's so many. There's 4 times 25. There's 10 times 10. Again, it doesn't matter. But I think I'll pick 10 times 10 this time. All right, so I have my 2 10s there. So the question you ask yourself, are these numbers prime? And the answer is no, because I know 2 times 5 is 10. So here's my branch. I'm making my tree. 2 times 5 goes with that 10. Here's my times sign. I'm bringing down between the 2 factors that I had. And now I'm going to go ahead and I am going to break the other 10 up into 2 times 5. Looking at all of these are prime numbers. So that could be my answer. But writing it in exponential form, I have 2 2, so I'm going to put 2 to the second power, or 2 squared, times I have 2 5, so it's 5 to the second power, or 5 squared. So either one of these answers would be correct if you were writing the prime factorization of 100. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.